Okay. What we have here is we're going to talk about some problems that are in our homework, and this deals with finding derivatives using the difference quotient and the definition of derivative. Now, just real quick, just to re-emphasize the definition of derivative. The definition of a derivative, which is a slope of a curve, okay, so actually this is the definition of a derivative, is a slope of a curve. We use the limit definition where I'm going to use the limit of f of x plus h minus f of x all over h as h approaches 0 as what we're going to call as f prime of x. Now, in this case, we're going to find these three different things by using this definition. Now, first off, we're going to find the slope of the curve. Now, the slope of the curve that we're looking for here is the curve of this parabola. And if you want to graph that, you probably can graph it really quick, sketch the graph. We have 0, and we have a 4, 1, 2, 3, 4, if I factor that through. All right, and this is opening up, so we're going to have a curve like that. And we're looking for what is the curve at 1. So here, I'm looking for what's the slope of that curve there. And in this case, I'm going to just draw a little tangent line, because that's essentially what we're looking for. We're looking for the slope of the tangent. All right. Now, to do that, we're going to use that equation up there. So we're going to look for what is f prime of 1. Now, f prime of 1, using the limit definition, we're going to take the limit of, as h approaches 0, and we're going to take f of 1 in this case, plus h, minus f of 1. So we're going to take 1 plus h and plug it into this function. So we're going to have x 1 plus h, the quantity squared, minus 4 times 1 plus h. Okay, and that is what f of 1 plus h is. We're then going to take this, and we're going to subtract f of 1. Now, if you plug in 1 in here, 1 squared is 1, minus 4 times 1, which is negative 4. So 1 minus negative 4 is negative 3. So we have that all over h. From here, we're going to simplify and solve this, because as we approach 0, we get 0, 0, which is known as indeterminate form. So we're going to simplify this now. So I'm going to do my algebra, blah, and we have 1 plus 2h plus h squared, factor through the negative 4, so we have negative 4 minus 4h, that great group, plus 3 all over h. From here, what we're going to do next is we're going to simplify, so we're going to add the 1 plus a 3, which is 4. That happens to cancel out with the negative 4. We then have 2h plus the negative 4h, that's going to give us negative 2h's, plus h squared all over h. Factor out an h, we have negative 2 plus h over h, cancel, cancel, and let's finish our limit up. Limit as h approaches 0, and that's going to equal negative 2. So our slope here for our tangent line is actually f prime of 1 equals negative 2. And that made sense because if you looked at our graph, and our graph was actually accurate, it's going down. Now, that's the slope of this curve here, all right, of that tangent line. It's negative 2. And we use that by using the definition, limit definition of a derivative. Now, the next thing we're going to do is, in part B, is we're now going to find the equation for this tangent line, which is here at 1. Now, to find the equation of tangent line, what we need is a slope and a point. A slope and a point. I'm going to put this in point-slope form. So we know our slope is negative 2 for this line. And I know that we're using 1 for our value. But now I need to figure out what is f of 1. What is f of 1? Or for our function. Now, right here I don't have f, but we'll call this f of x. Just so we're aware. All right. And for that one, we're going to take that. And we're going to say, we're going to plug a 1 in there. So we're going to find what 1 is. And 1, when we already did that, was going to equal negative 3. So our final answer is y is going to equal negative 2 times x minus 1. It's going to be minus 3. And that is the equation for our tangent line. Now the next one that we want is we want to figure out the equation of a normal line, the normal line. Now the normal line is the line that is perpendicular, so if you're not familiar with this, the normal line is a line perpendicular to the tangent line. So to find that equation is actually pretty simple, all right, because what we're going to be doing is I'm going to draw a line that's perpendicular to this tangent line, okay, and to do that, all right, so the normal is, if you recall, a normal line, which is perpendicular to tangent, is just the opposite reciprocal slope. So we're going to have a line, take our slope, take the opposite reciprocal, which is 1/2, and our point is the same, and that is our normal line. So in this problem, we did several different things. What we did was we used the limit definition of a derivative to help us figure out the slope of the curve at the given point, which is x equals 1. We found that would be -2. We then found the equation of that tangent line, right there in blue. And then we found that it's normal, which is perpendicular right there. So I hope this helps out going through this problem of how to find derivatives and how to use them to find equation of tangent lines and so on and so forth.